Okay, so let's stop to review for a minute. We have two rules that we've just talked about that are very important to us. Descartes' rule of signs to determine the possible number of positive and negative real zeros, and the rational zeros to get a test list of our rational zeros of p of x. So what do we have to do? We can actually determine a lot of information from this function from just these two rules, along with our leading term test about the left-hand, right-hand behavior of the function, and nothing else. Let's take a look. P of x equals 2x to the fifth minus 3x to the fourth minus 19x cubed plus 27x squared minus plus 35x minus 42. So what do we know? Well, by Descartes' rule of signs, if we just look at the basic function itself, p of x, how many sign changes are there? Well, we go from positive 2x to the fifth to minus 3x to the fourth to minus 19x cubed to positive 27x squared to positive 35x to negative 42. So that is one sign change, two sign changes, and three sign changes. So what we could say right now is that there, by this rule, could be three or possibly one positive real zeros. Remember, it's equal to the number of sign changes or less than that by an even number. All right, let's check out p of negative x. P of negative x, remember, changes the sign of each of the terms if they have odd powers, right? We're going to have 2 times negative x to the fifth minus 3 times negative x to the fourth minus 19 times negative x to the third plus 27 times negative x to the second plus 35 times negative x minus 42. So if we look at the sign changes right here, this will become a negative term, negative 2x to the fifth. This will stay minus 3x to the fourth because negative x to an even integer exponent keeps the same sign, just makes it positive. Plus, this will become plus 19x cubed because we're taking negative 19 times negative x cubed. We're going to have plus 27x squared. We're going to become negative 35x in the next term, minus 42. So now we look at the sign changes here. We see that we go from a negative term to a negative term to a positive term. There's one sign change. Positive to positive, positive to negative. There's a second sign change. Negative to negative. No more sign changes. So we will have two sign changes indicating that it's either equal to that number of sign changes or less than that by an even number, that is 0 negative real zeros. Okay, and what does that mean to us? Well, it's possible that we could have one place on the x-axis or three places on the x-axis to the right side of the y-axis. We could have 2 or 0 on the left-hand side. So we might get no negative numbers that are zeros. Or if we get 1, we know we'll get at least 2. What does the rational zeros test say? Well, the rational zeros test says that if we get a list of possible rational zeros in the form p over q, they will be equal to positive or negative factors of the constant term divided by factors of the leading coefficient. Well, our constant term is negative 42. We need factors of 42. Well, what are they? We know that 1 is a factor of everything, so we include it on the list, but 42 is divisible by 2. That would be 2 times 21. 42 is divisible by 3. 42 is definitely divisible by 6, as well as 7. Let's see, 6 times 7 is 42. 3 times 14 would be 42. 2 times 21 would be 42. And of course, 42 and 1 itself gives us that list. Our leading coefficient is 2, so that's easy. 1 or 2 is our list of those possible factors. So our list of possible rational zeros are going to be plus or minus 1, or plus or minus 1/2. It'll include plus or minus 2. We don't need 2/2 because that's 1 again. Plus or minus 3. Plus or minus 3/2. Plus or minus 6, but we don't need 6/2. Plus or minus 7, or plus or minus 7/2. Plus or minus 14, but not 14/2 because that's 7. Plus or minus 21, or possibly positive or negative 21/2. Sort of an extensive list, but much shorter than just random guessing, right? And plus or minus 42 makes up our entire list of possible rational zeros. Now, if we think about the way this function is going to look, what could happen are the following possibilities. If there are 3 positive real zeros and 2 negative real zeros, our graph might have 3 places along the x-axis where it's going to cross, and 2 places where it's going to cross, so a total of 5 possible real zeros. Right? That is our maximum. Now we could have a graph that passes through the x-axis in no places to the left, but 3 places to the right. We could also have a graph that passes through 2 places on the left and 1 place on the right. Remember, our graph has this odd power leading coefficient that's positive. Right? Or our graph could be the kind of graph that only passes through the x-axis in 1 place, and that is to the positive side of the x-axis. So our graph's zeros would look something like this, and these are the possibilities according to Descartes' rule of signs. And so if we were to start guessing, we would want to start guessing by looking at these numbers right here. Well, this is sort of a long problem. It would take us a long time. So in our next examples, we'll try and shorten it down a little bit and show you how all of this works together to generate the graph of a polynomial.